Hello, everyone. This is the sixth Bevy virtual Bevy meetup. I'm Stefan, and I'm super happy to welcome you to this edition. It's been a while now, and we have a super interesting lineup for today. But as usual, let me start with a little standard introduction. This is the Bevy Game Development Meetup, and we're going to have three amazing speakers today. It's our sixth edition, and as usual, we're going to aim for 15 to 20 minutes of each talk with 5 minutes of Q&A. And if it goes massively over and we have a lot of this conversation, we are free to have a panel discussion at the end. As you can see it on live stream now, it's recorded and streamed. So after the event, the individual recordings will be published. The code of conduct: be kind, be respectful, be curious, ask questions, reach out if you have any concerns. If you see anything that you need to share or that you need help with, feel free to reach out to me. And I'm Stefan. I'm using Rust since 2017. I'm in the game development sphere for 17 years. I created some open source projects that you might have heard of, Git UI and LifeAsk. We were going to be using LifeAsk here today. And the meetup is sponsored by Rust Unit. I founded Rust Unit, and it's a consultant agency for any kind of Rust projects, but also video games in Rust with Bevy. So feel free to check out rustunit.com. And I mentioned the Q&A part already. Please scan the QR code. It will be on the bottom left of the screen all the time. If you have any questions that you would like me to share with the speaker at the end of their presentation, this is the best place to post them so they don't get lost in chat. And there's also a link in the description, of course, to find that as well. That is already the simple introductory part. So without further ado, I'm going to pull up our first speakers for today. And we're going to have Zicklag. Hi.
Hi there.
Welcome. I'm going to put up your slides and leave the stage to you. And I'm super curious to hear how Bevy and Bones play together, and how can someone accidentally make a game engine. So please take it away.
Okie dokie. Hey everybody, I'm Zicklag, and I've been working on Rust game dev on and off for the last 5 years. And I started using Bevy when it was publicly announced 4 years ago. I'm self-taught, and I've been learning everything from Rust graphics, programming, and just trying things out and doing whatever I needed to get stuff done. I'm super excited to be here, and today I'm going to talk about the journey me and the Jumpy community took as we accidentally made our own game engine. So a question you might be asking at this point is, isn't this a Bevy meetup? And of course it is. But as you'll see, our engine, Bones, has learned so much from Bevy that it would have been completely impossible to make Bones without it. And Bones is kind of like Bevy's little brother. And that brings us to, what is Jumpy? Jumpy is a 2D multiplayer shooter game. It's all about great local play, fast reflexes, and importantly, modding. 2 years ago, when I took over as the lead developer for Jumpy, it was already using MacroQuad for its engine. I had more experience with Bevy though, and we were already using Bevy for another game, and we could share a lot of the knowledge and resources between them if we used Bevy for both. So we decided it would just be the best option for us to rewrite Jumpy to run on Bevy, and I was really excited. I started working right away, and things went really well. We got the maps loading and physics ported, the main menu, and we even had to start to an in-game map editor. And it was all in pretty good time. And then came the real challenge, and something I had never done before. That was networking. I started off by trying the simplest thing I could think of, a headless Bevy server that synchronizes transforms with the clients. While this kind of worked, the skipping was completely horrible. It was just unplayable. It also had a bunch of networking code that we had to add mixed in with the gameplay code, which was annoying and complicated. Like when you used an item, it now had to send a network message so that the item would get used properly across the different clients and such. It was just hard to maintain. And then the game was different on the network version than it was on the offline version. So I did a bunch of thinking and research and realized that to fix the skipping and get the gameplay smoother, you had to compensate for the network latency. And that meant syncing with the server and then fast forwarding the game in the background before you display the frame to make up for the network delay. That looked like it would be possible, but if I was going to go through all of that trouble, I thought it was worth looking at another option first. I had heard of peer-to-peer rollback networking, which was really cool because it didn't require a dedicated server. The clients could connect directly to each other instead. On top of this, the gameplay code could stay the same during network and offline play instead of having to mix network messages in with the normal gameplay. The caveat was that the gameplay had to be deterministic, and you had to be able to create and restore snapshots of it. Jumpy is a simple game, so that didn't sound like it'd be too hard. Lucky for us, Bevy also had a plugin for peer-to-peer rollback networking. So we started testing out the Bevy GGRS plugin, and we were really happy with how much it simplified the game's code. But we started to have some serious problems keeping the game deterministic. Bevy is designed for maximum performance and multi-threading, and that's often in conflict with determinism. Doing normal things like iterating over a query turned into a problem because now we had to collect the query results into a vector and then sort them to make sure that the iteration order was deterministic. Many things in Bevy are impossible to snapshot and restore. So the more things we did, the more gotchas we found. We couldn't use global transforms, we couldn't use local system params or events. These were all things that were like super easy to miss. And now with every change we made, we risked unintentionally breaking the determinism. This is really bad for new contributors and just for overall development peace of mind. So I did a lot of thinking about what it would take to put Jumpy's core gameplay logic into its own deterministic box, so to speak. We can make our own tiny ECS and make the whole world clonable so that it would be trivial just to snapshot and restore it. I started off with Plank, the simplest Rust ECS I could find. We forked it, we called it Bones ECS, and made just a couple tweaks to make it more suitable for scripting. But scripting would come later. Now we started migrating the jumpy gameplay code from the Bevy ECS to the Bones ECS. This was the biggest rewrite, and there was a lot more boilerplate than I imagined, but we did finally get the game working again, and we had a very interesting architecture. When the game starts up, it shows the menu and it's just a normal Bevy game. But when you start a match, it creates a new Bones ECS world and starts sending the controller inputs to it through GGRS. The jumpy gameplay code all runs inside the Bones ECS, and it creates entities for the sprites, cameras, tile map, etc. On each frame, a Bevy system will then read all of the sprites out of the Bones world and render them in Bevy. So as a player, it looks like nothing has changed. On the inside, though, GGRS is able to make snapshots of the Bones world whenever it needs to, and all the gameplay inside is completely deterministic. It was working, we had network games, and we were excited. Things weren't perfect, though. For one, now we had two ECSs to deal with. This was confusing, especially for new contributors, and there were other annoying things like having to put the GUI stuff in Bevy and the gameplay stuff in Bones. So we started to work on a unified Bones framework. The framework would allow Jumpy to use Bones ECS for everything, but in the background, we would still use Bevy for rendering. The first step to creating the Bones framework was to make a proper asset server. We had this planned since we had started working on Bones ECS and realized that integrating the Bevy asset server was not working very well. We had to do like handle translations and stuff. It was just kind of cumbersome. We'd also had some very specific goals around modability. For one, we wanted user asset packs to be first class citizen. We wanted uh, basically our own organized way to load asset packs in the game. And for two, we wanted a easy way to load all of our game config and assets easily through YAML files. So we had already had this set up with Bevy where we could use a derive macro to automatically generate asset loaders from Rust structs so that we could load the Rust structs from YAML files with Sirdi. Things got complicated though when we wanted one YAML file to be able to reference another YAML file or another asset. It kind of worked, but it was kind of a pain, and it was like half automated and half manual process. Having our own asset server would let us support both these use cases seamlessly with a first-class developer experience. And it would also help with scripting in the future. When it came to our YAML asset system, things were a bit harder than I expected, and that was because I was trying to support runtime defined asset types. The use case was for modding. So currently, each of our YAML assets were derived from a Rust struct, and the loader wouldn't load the YAML if it didn't have exactly the right fields for the Rust struct. I wanted to keep this type checking, but allow mods to define their own types that didn't exist in Rust. So we wanted something kind of like a JSON schema for our asset types. After some experimentation, I realized that this was exactly what we need for scripting too. This spawned the development of the Bones schema crate. Bones schema is very similar in purpose to Bevy Reflect, but it works quite differently. Where Bevy Reflect uses trait objects, Bones schema defines a stable memory layout. Basically, you derive the has schema trait and you add the reper annotation to your struct, and now you can get a schema describing the exact memory layout of the struct at runtime. It can also be created for types outside of Rust so that you have a schema describing a type that doesn't have an equivalent Rust type. Once we got this working, it actually simplified our ECS code quite a bit. It made the whole ECS compatible with runtime defined types. It was a huge step in the direction of scripting. After a lot more work to get everything tied together, we finally finished the Bones framework and finished migrating Jumpy to it. Now Jumpy was 100% a Bones game, and there was no longer confusion around having two entity component systems. On top of that, Jumpy and the Bones framework were now renderer agnostic. We are currently using Bevy as our rendering backend, but we could easily use anything else. In Bones, we only have four different kinds of renderables at its core. We have sprites, tile maps, debug lines, and EGUI. Any renderer that could display those four renderables could be used as a rendering backend. We could also integrate with Bevy plugins if we wanted to later for things like particles and 2D light effects. It wasn't totally restricted. We could add what we needed as we did. Now that we had Jumpy migrated, we were tantalizingly close to supporting scripting, and we had been waiting for this for a while. We had already been in contact with the author of the Piccolo Lua VM in anticipation of it, and all we had to do now was plug it in, or hypothetically anyway. It turned out to be a lot more work than we thought, and like every other step in the process, but it was worth it. We were finally able to demonstrate adding a brand new item to the game with a Lua and YAML asset pack. Personally, this was a huge deal. I had been working on getting modding into multiple game engines for nearly 8 years, starting with Godot, and every time I failed. But finally, this time it was working. And that brings us to today. Bones continues to work really well for Jumpy, and we really like it. It does exactly what we need, and we're free to grow it however we need to, along with Jumpy and our other games that we'll be building on Bones. Something that we want to do in the near future is to try to make our own renderer for it. Bones' rendering needs are really minimal, and right now pulling in Bevy and its ECS and its reflection system and its renderer is just a lot more than we need for Bones. Also, properly integrating Bevy's renderer with Bevy's renderer basically means we have to write a custom sprite pipeline for the Bones world, which isn't really that much easier than writing our own renderer right on top of WGPU directly. We're hoping that this will cut down on dry compile times, which are they're not the most important thing in the world, but it has been an impact to new contributors. So it's something we were just hoping to trim down a little bit. So we never meant to make a game engine. We started just building these pieces bit by bit that we needed, and it ended up coming together even though we had never planned on it. And even though we didn't plan on it, we're really happy with the way it turned out, and we couldn't have done it without Bevy. Bevy allowed us to continue working on Jumpy, which was really our priority, while making Bones piece by piece. Bevy was so modular that we could combine it with our own ECS, with our own asset system, and with all of these different pieces as we went, however much we needed for our game. And we learned so much from Bevy. Like, so many different pieces of Bones are just simplified versions of what you get in Bevy. It Bevy's design, discussions, and everything, it just helped inform the way we made bones in so many different ways. So, to everyone who helped make Bevy what it is today, thank you. We couldn't have made the game without you. So, now I want to take some time to do a short tour of the bone schema system. The schema system is probably the most interesting and original pieces of Bones, and it's also the piece that could be most useful to other projects outside of Bones. So it'll be fun to take a closer look at how it works. First, we're going to look at the simplest thing you can do. Here, we've just got a simple position struct with an X and a Y field. We're just going to derive has schema, clone, and default on it. The has schema trait has just one function, and it returns the schema associated to the type. To see what that looks like, we're going to get our position schema and debug print it. As you can see, we get a lot of stuff here. We're going to look at just a couple things for the moment. We can see that the schema tells us the short name and the full name of our type, which is really handy for debugging and for figuring out which type to import by name in scripts. We can also see what kind of data our position is and take primitive type. Since it's opaque, all we know about the type is its size and its alignment. That's not very much info, but it's just enough that we can insert it, for example, into an ECS. If we want any kind of scripting superpowers, though, we need more info. That brings us to the Rapier annotation. Here we have the exact same sample, but with the added Rapier annotation to our struct. Now when we run it, instead of seeing an opaque primitive type, we see a struct type. The struct tells us the fields of the struct, the names of each field, and finally, by looking at the schema of the X field, we can see that it's a primitive F32 type. The schema now has enough info for scripts to come in and edit the memory of the struct without triggering undefined behavior. The schema tells us what can safely be done with the data. And now we're going to look at what kind of abilities this gives us in Rust. We'll start by adding another struct, in this case, the velocity struct. And we're going to create an instance of both a position and a velocity. Next, we stick them both in their own schema boxes. So a schema box is one of the most used types in Bone schema, and it's in fact very much like a box dynamy. By putting the position and the velocity in boxes, we erase the type, so to speak, so that even though they are different types on the insides, they're the same type on the outside. This lets us do things like stick both of them in the same vector, which is impossible normally because every item in a vector must be the same type. Now we can loop over each box and we can try to cast it to a specific Rust type. In this case, we try to cast it to a position and print out the positions fields. Or if that fails, we can try to cast it to a velocity and print out the velocities fields. And this isn't really that different than what you can already do with a box dynamy. So let's get a little deeper. Because the schemas now describe our fields, we're able to access them by their names at runtime. Here we have the same example as last time, but we modify the loop. Instead of trying to cast it to a specific Rust type, now we can use the asRef function to get a schema ref, which is similar to a reference dynany. Unlike dynany, though, we're able to extract fields by name from the reference. We use the field function to get the X, try to get the X field, and we unwrap it, which would fail if it didn't have an X field. And then we try to cast it, and we unwrap that in case it's not an F32. And we end up with our reference to F32, which we can print and show that we are able to extract the X field from every item in the list, even though one is a position and the other one is a velocity. This kind of ability is essential for scripting and also very useful for things like ECS World Explorers and stuff like that. We can also use Bone Schema for serializing and deserializing. For example, if we have this small YAML snippet that we want to deserialize into a position. We haven't derived the CRD deserialize trait for position, but we do have all the info we already need in the schema. So to start, we create a normal YAML deserializer from our YAML snippet. And this is just normal CRD YAML thing. Then we create a schema deserializer for our position schema. And we use that to deserialize the YAML data into a schema box, unwrapping it in case it fails. Once we have that schema box, we can try to cast it into its position and debug print it to show that it deserialized properly. This functionality is extremely useful in the Bones asset server, and it's how we automatically load YAML assets into Rust structs. So far, all of our schemas have come from Rust structs, but schemas can also be loaded from files at runtime, and everything works the same. This is crucial for scripts that need to be able to store their own components in the Bones ECS, even though there isn't a Rust type for it. And it's also how mods are able to define their own asset types, even though they may not exist in Rust. Finally, there's one more nifty feature I want to show you in Bones schema, and that's associated type data. Each schema has a type data store. It's just a container that you can put anything you want into. There are all kinds of things you can use this for, but it's easiest to explain with an example. Let's consider a potential use case in our ECS. When you add components to an entity, it allocates enough storage for that component on demand. If you were to spawn a bunch of entities, then it would reallocate storage multiple times. But if you knew that you're going to, for example, have thousands of our position component, it would be more efficient to allocate the storage for, say, 10,000 positions up front. We could indicate this by adding storage mode type data to our position component. For example, here we've defined a simple storage mode enum that has an on-demand option and a pre-allocate option. When we come down to our position, all we have to do to add it as a type data is use the type data annotation. And in this case, we stick storage mode on demand into positions type data. And that's all there is to it. I'll show you how to read that from its schema later. First, one more thing that is pretty nifty that we can do with type data is we can make them derivable. So here we have the from type trait, which we must implement from storage mode to make it derivable. This is a bit of a contrived example, but in this case, we just get the size of the type in bytes and we allocate 1,000 times that size for our storage mode. So whenever we derive storage mode on a type, it will just pre-allocate 1,000 times the size of the type. Then to use it, now instead of having to set a specific storage mode for our velocity, we can just derive type data storage mode instead. And it will call our from type function to go and generate the storage mode for the velocity struct. Finally, uh, we can try to use our schemas. So in this or our type datas. In this case, we'll just pretend like we're the ECS and we've got a list of schemas that we need to allocate storage for. We throw our position schema, our velocity schema in there, and also the schema for string, which we notice we haven't added a storage mode for yet. We can loop over the schemas and then simply do schema.typedata.get to try and get the storage mode out. And it's an optional storage mode because we may not have added storage mode to the schemas. And if we debug print it out, we can see that we have our on-demand storage mode from position, our pre-allocated storage from velocity, and none for the storage mode of the string. And there are a lot of possible uses for type data. In Bones, we use them to specify asset loaders and custom deserializers when the default one isn't sufficient. Eventually, you'll be able to use them to specify custom bindings to scripting languages. They're basically the traits of the Bones schema world. And like everything else in the crate, they focus on giving you more access at runtime to things that normally only work at compile time. And you'll notice a lot of this Bones schema is very similar to Bevy Reflect. It can do a lot of the same things, but we went with the schema system because it allowed you to interpret the types of the data without having to make function calls back to the main app. So if once you knew the schema, if you had like a C program, for example, you could do direct writes and reads from a pointer to that type. So you could read and write the struct without having to go and make a separate function call every time you needed to do something, um, because you were going through the dying reflect that you would have to do in Bevy reflect. I'm not sure if that helps performance. We wanted it to be as friendly to scripting as possible, so that was kind of the idea, but that's all untested. And really, it's just our own different take on how to do the runtime reflection. And that wraps things up. I'm super accomplished with what we've accomplished so far, or super excited about what we've accomplished so far. I'm really grateful for all of the work everyone's done before us and everything we were able to learn from. And I can't wait to see what's going to happen next. Bones and everything in it are public on GitHub, so if you're interested, you can check it out. We'll have a Q&A session here if you have any questions, and if we don't answer your question, feel free to reach out to us on Discord or GitHub. We're always happy to chat. Thanks for having me on here, and thanks for listening, everyone.
Thank you so much, Zicklag. That's a super exciting project. I want to start with one quick question that I had myself. What you showed at the end was super exciting in terms of the whole dynamic system that you built there. Is that already used in the game that you showed, Jumpy?
Yeah,
Is the game logic actually built on it?
So the game logic, the whole ECS, that actually underpins like the whole ECS. Like every time you store a Rust type, it's actually using its schema to make sure it allocates the right storage and stuff. And it's not necessarily providing a lot of advantages until you get into adding Lua scripts, and now Lua can add their own types and stuff like that. So we're not extensively using like Lua mods yet. We have like an item in the game, but that system is still being used in everything, and it's actually how we get all of our assets loaded and stuff like that. So it's used throughout, but we haven't used Lua specifically a ton yet.
Are you also planning to support other scripting languages than Lua?
We're not 100% sure what we're going to build into it, but it's absolutely possible to support anything other than Lua. I had done some work with JavaScript scripting for Bevy, with the Bevy mod.js scripting plugin, and so I got a little bit of familiarity with the Dino bindings to V8 JavaScript engine, and we could probably do that. The logic for the Lua one was because it's common in lots of game modding circles, but also because the Lua VM that we had was 100% Piccolo is 100% safe Rust from the user interface, or as us. So we don't have to write unsafe to talk to the Lua VM, which was very cool. Kyron, who the author, has done a really great job on it, and it ran in web without modifications, because when we used JavaScript, we tried to use the browser's JavaScript engine, and we ran into serious performance problems every time we had to jump back and forth frequently for the JavaScript. So that web support was probably our biggest guiding factor there, but it's not hard to, since all of the dynamic features are already there, it's not hard to like add new scripting languages. It's more tedious. But no, it's definitely something that we want to something we're open to for different languages and stuff like that.
Yeah, that's pretty cool. And so the highest ranked question that I see here is: are you still following Bevy's development? And what do you wish Bevy would learn from Bones?
Oh, that's an interesting question. So honestly, Bevy's obviously doing a lot of really awesome stuff. What we found out was Bevy is just a different. It's just got a different niche, so to speak, or a different end use case. All of its performance focus wasn't what we needed for our small 2D game that we wanted with to do networking play on. So I'm not sure that Bevy has much to learn from Bones, as much unless it's just realizing that there are use cases that it doesn't cater to as well as we felt like we needed what we needed. So I think it's really just a different focus. So we're kind of we're definitely like, we don't multi-thread. We've left that option open. So we by no means restrict you from multi-threading, and we have some ideas for that later. But we're focusing mostly on maintainability for a small code base and just adding only what we need as we need it. Whereas
Mm.
Bevy has, I mean, 3D is a huge topic in itself. It's got cool new 3D rendering stuff, every release and all of that stuff. So it's obviously way faster and it's massively parallel and all of that stuff. So Bevy's definitely better if you want to build something that is going to really take advantage of all those things. So we're probably more comparable to like Macro Quad or Comfy or one of those smaller, or Good Game Easy or something like that. So
Mm.
we're kind of like, but we're still ECS based. So we really just took Bevy and shrunk it really.
Mm. I mean, that actually ties into the second question that I see here. Like, why did you end up using a different ECS crate instead of using the Bevy ECS that was already a separate crate, I think, when you started, or pretty early on, right?
Yeah, no, that was already separate crate, and Bevy's again done very good at modularizing things. But the Bevy ECS was not like snapshotable, so
Ah, so that was it.
we
Yeah.
couldn't just like clone it, and
Mm.
when you iterate over it, for the sake of performance, the items come in a random order. So we were really kind of like, okay, and initially we didn't plan on making like a whole engine thing. I was just like, okay, I still want to use an ECS, but if I can't use Bevy's ECS, I'll just make vectors, or I'll just do like the simplest, dumbest thing.
Yeah.
And that simplest, dumbest thing was pretty cumbersome, and it grew as time went on. But so it was really mostly just around, can we just do things in the same order every time? And even
Mm.
the system scheduler runs stuff if you don't enforce an order, it runs it in a random order. So all of those things, it was just kind of, it wasn't helping us very much because 2D pixel game, like we don't need the performance, and
Mm.
it was providing a barrier at that point. So we were kind of
Gotcha.
just going for the easiest way out.
Mm. Yeah. You mentioned also compile times, and the question is, how does it compare to full? Like, if you compare maybe a game that you built in Bevy with a game built with Bones, is that significantly different in terms of compile times?
Um, so right now, um, Jumpy or so Bevy by itself doesn't have much, or I mean, Hello World Bevy compiles way faster than Jumpy does, because we've included like a multiplayer networking stack with hole punching. We have a Lewis
Mm.
scripting engine in it. So it's not like that Bevy is much bigger. It was just that Bevy has more stuff. We've kind of got two engines now. So while we've already got Bones ECS, we've got a Bevy ECS too. While we've already got Bones Schema, we've got
Mm.
Bevy Reflect too. So it's not that like Bevy compiles slower than Bones, or at least I'm not sure if it does. We haven't like done that kind of comparison, but
Mm.
it's that we are already adding a lot of stuff to Bones because we want to build in networking. We're building in all of this stuff, so it's all easy to access. We build in Lewis scripting. Obviously, you can opt out, but um, so then just having duplicates of some of this infrastructure for our already long compile times, because we're pulling in all this extra stuff, it's just something that we could kind of trim out. And and then the other thing was usability, because we had a way that we could extract our bone sprites into the Bevy render system. We could kind of like cheat and steal the Bevy sprite pipeline, and just we would inject a system into the Bevy sprite pipeline that would go and read our sprites as well as Bevy sprites. But
Mm.
on a recent release that broke, and I think we have to write our own sprite pipeline now. So then we kind of have to get into rendering again. So then it was like, okay, if I'm already like having to kind of write a proper Bevy pipeline now, then
Mm.
it's probably not that much more easier than just writing a WGPU rendering pipeline, which again, we don't need render graphs, we don't need anything.
Mm.
I've thrown sprites on the screen before with raw OpenGL and stuff like that. So it's not that big a deal when all we have is these 4 renderables and we just spit it out on the screen. So
Yeah.
we're being we're shrinking everything, and in that case, it just seemed
Mm.
like, let's not make our contributors pay for that. And I mean, even in our case at this point, we're like, maybe it'd just be easier to write a custom renderer for this piece at least.
Mm. Yeah, I mean, it's not a fair comparison because it's sort of like both still in one package, at least up until now, right? So in terms of compile time, it's like build Bevy and then build the rest of Bones.
Build at least a chunk of Bevy, then build, a massive
Yeah,
hunk of bones. So
yeah.
yeah, it's really just a
Okay.
way for us to trim stuff out.
Yeah, yeah. And I mean, at the end, there will be probably a comparison possible once you have your own renderer. Like, how much does it really change now in terms of compile time that the whole entirety is gone
Yeah,
from Bevy, right?
yeah,
Okay, cool. Zicklag, I would move on to our next speaker and defer the remaining questions to our conversation at the end. It was a pleasure to see what you're working on, and yeah, I'm hoping that both systems can learn from each other, and I'm also excited to see
definitely.
what's going to come out based on Bones. Thank you so much.
No, thank you.
Okay, so now I'm super excited to actually present the second speaker today, who is a familiar face actually for this program. He has been speaking already before. I think it's the second speaker return that we have here. And yeah, I'm going to put Thierry on stage here. Welcome back, Thierry.
Hello, thanks.
Great to have you. And I'm super excited to see what you've been up to lately. So here are your slides, and I'm going to leave the stage to you. Thank you so much.
Thank you. Yeah, thanks, Stefan, for organizing, and thank you everybody for tuning in. It's it's the second time that I'm here, and for those who remember them, you may remember me from that I was a game developer using Unity, and I have great news to share with you because since then I've quit my job and I'm now a freelancer, and I'm currently helping with maintaining Rapier, a physics library. So I touch up some techniques, not maintenance, some future-proofing techniques applied to Rapier. So Rapier is a physics engine, and what is a physics engine? It's about shapes colliding, sliding, and constraints being applied, like rotation constraint, positional constraints, and stuff like that. And there's also a whole scene querying things to shapecast, raycast, and stuff like that. So what's the plan today? I will tell you a little bit about documentation. I will tell you about tests, and I will tell you about systems. Well, I'm not telling you too much about the third subject. A little bit of context more. So Rapier is a Rust crate about physics, so you can use it as a Rust dependency, but you can also use it as in JavaScript because we have official bindings for it. We have official bindings for Bevy, and also like semi-official bindings for Godot. It's made by a community member, but the documentation are live on godot.rs and godot.rapier.rs, which is our domain name. So it's like semi-unofficial thing. So yeah, check it out if you're interested in that. Our first subject is documentation maintenance. So if you want to learn about Rapier, the most effective resource is probably rapier.rs, our website. And it's not docs.rs. It's a custom, it allows us to have custom rendering, but it also brings some difficulties, like, is this compiling? Yeah, to better understand the subject, let's go into how it works. So Rapier.rs uses Docusaurus. It's a static site generator made by Meta, Facebook. So you have Markdown with custom tags for each user guide. It's custom. It's made by our. It's custom made. So it's a set script basically, and it's retrieving each code snippet for each user guide to have very specialized user guides. And then in the end, the user guide looks like this with the code embedded into it. And yeah, how it's a bit difficult to maintain, because how do you verify if each code snippet is working? I was tasked to copy every line of code, and it doesn't help that most code snippets need some kind of setup. So I was, okay, I'll do it, but I really don't want all that tedious time consuming task to go forgotten. So I created multiple projects with those code snippets, so I could manually run cargo check on those and verify that everything is compiling. And that cargo check can run in CI, so we can have it in every pull request. And those code snippets are also injected within the web, within the Markdown, to be fed into Docusaurus. So we have an additional pre-build step. And yeah, so we can more easily assess that it's compiling all our website stack. It's not really specific to Bevy, this technique, because we're using the same thing for Rust and JavaScript. Well, JavaScript is a bit different because it's not really type thing. I don't want to go into much detail, but I went into TypeScript to have somewhat of a compile time checking. But yeah, it's interesting that Bevy can use this kind of technique for that. Whew, okay, other subject now. This time very specific to Bevy. Tests. On a great day, we had a bug report about a crash when removing a collider. First thing, I tried to have a minimal project to reproduce it. So you can see here it's quite small. You have a first system setup physics, which creates a lot of colliders when creating the app, a lot like 10,000, I don't know. And then the system remove collider, remove exactly one collider each frame. And then we are running the simulation for 100 frame as fast as we can. And yeah, we can use some debugging and stuff. And at first it wasn't reproducing the crash, but there was enough information in the report to guess what was the problem. And I have to tell you a bit about a technique in simulation, sometimes for performance reason or other things. You're not simulating the world every frame. You're simulating the world, rendering the world, rendering the world, rendering the world, then simulating the world, then rendering, simulating, rendering, simulating. I don't know, you get it? And the crash was happening when we were removing a collider, when we were not simulating the world. And with those line of code, what they do, this code snippet with manual duration, it's like hard coding, it's faking a frame time of 60 frames per second while still being able to run as fast as possible. And then I'm configuring the Rapier configuration to run 30 frames per second. So it's half the time. So it's effectively running the simulation every other frame. So as we remove a collider each rendering frame, it was crashing at the first frame we were not simulating. And bam, a great test-driven debugging. TDD, is that debugging? I don't know. But yeah, and that's very interesting to be able to quickly have a very focused test with Bevy. It's the power of modularity. Zicklag was telling you earlier about that. And yeah, you can add quick debug lines, and you can also fire a debugger. And that's when I fired the debugger and went into the deeper stack stack frames of the program that I could debug it fast. And I won't tell you about how I debug or the exact fix, because it's less interesting than the test, in my opinion. But you can check it if you're curious. Now that's our last subject. It's about systems. So systems are a piece of logic running on data. It's reading or writing data or both. Well, but I don't want to tell you about systems. I want to tell you about system ordering. So every Bevy app has schedules, and which are responsible for providing a rough execution plan for the systems. But I don't want to tell you about ordering. I want to tell you about systems ordering ambiguities. That is when the schedule don't have enough information to know if a system A runs before system B. So they will choose at random to the order. But don't confuse it with this kind of stuff. The schedule really wants to optimize things. So if it can, it will be able to run systems in parallel if they are not, if they read the same component. It's not, it's not a problem to run them in parallel. So yeah, don't confuse it with that. I want to tell you about conflicting systems ordering ambiguities. The name is longer and longer. So if I have a system which reads a component X, system A reads component X, but system B is writing component X. So those systems will be conflicting. It's kind of like the borrow checker rules, if you may. And it leads to bugs difficult to track, because you can have a lot of bugs, but one that I'm familiar with is one frame delay. When on one frame, there is a system which writes on a component, and then the other system is reliant on that first system to have up-to-date information, and it can lead to, I don't know, mostly the rendering, stuttering, and stuff like that. And to fix that, you can order your system. But again, I don't want to tell you about how to fix that. I want to tell you about how to debug. So conflicting systems ordering ambiguities, debugging. For that, I recommend you the create Bevy mod debug dump, which outputs this kind of graph. It uses graphviz.graph. And you can see the execution, the rough execution graph of those systems. And why is it important when debugging ambiguities? There is a built-in rendering for ambiguities. Here you can see that there may be one frame delay on the animate targets and inherit weights. On a given frame, you probably want your animation to have the correct morph weights applied to them. So yeah, it's probably missing something. And by the way, this is from Bevy official default plugin at the time I wrote those slides. You can check it out at this URL. It's made by the same author as Bevy mod debug dump. It's an online snapshot of default plugins. And you can see here that there is a few ambiguities, and it can be overwhelming. So these kind of systems ordering ambiguities are sometimes not too easy to debug, and having tools like this are very important. But if you're overwhelmed by the engine, by Bevy's ambiguities, it's difficult. So I created the pull request to Bevy to have a non-regression test to avoid making it worse. And since then, Alice came in, thanks Alice, and reduced all those conflicting systems ordering ambiguities to almost zero. So thank you, Alice. And oh, by the way, I'm making a Bevy themed physical card game, but again, I don't want to tell you about that today. I can focus on fixing my ordering ambiguities But the title is too long. But yeah, I will go back to that. That's it. Thank you.
Thank you so much, Thierry. Yeah, that was a lot that you did not want to talk about today.
Yeah, I want to come back. That's fine.
Yeah, nice one. So yeah, we have. I see two questions here. So let me start with the first one. What do the arrow colors mean on the chart that you showed? I guess
it's selected at random. It's completely random. There is some theming capabilities built in Bevy mod debug dump. I'm not sure if the color of the arrows are configurable, but it could be done quite easily. I skimmed through the source code. Yeah.
If you, I just segue into my own question that I have around this. So if you use this tool, I imagine if you use it on your big game project, it's going to be a huge, enormous graph, right? Right, because it will be containing not only Bevy itself, but also your own code. Is there clustering happening to make you aware of your own stuff instead of being
yeah, you can filter it out. You can filter it out. So it's
okay.
you have the whole path of the system. It's first of all, it's separated by schedules, because I believe schedules are not aware of the other ones, and then you can filter them out by their name, and their name are the whole path. So for Bevy, there will be Bevy render, animation, stuff.
Yeah, that would make it easy. Okay. And then we have anything on the Rapier roadmap that you would like to share with us?
Well, I did want to speak about Paris. I'm working on a lot of examples for Paris using MacroQuad for simplicity. But yeah, it's a lot of moving shapes, raycasting, and stuff like that, which are quite handy to understand how to use the library.
Yeah, okay. And a personal question from my side, is there any plans to allow GLAM instead of a second math library?
No. But yeah, I'm also frustrated by the interaction between GLAM and algebra. It's a tough subject.
Yeah, I can imagine. Well, okay. I had to try at least. Okay, Thierry.
I hear you.
Thank you so much, and I'm excited to see what this card game project is going to lead into, and I'm expecting a lot of updates from you on the Discord there.
Yeah.
Thank you so much, and 3 times the charm, right? See you soon.
Yep. Bye.
Bye. Okay, so now it's time for our last speaker for tonight. I'm super excited to hear more about his topic and what he's working on. Jillis is actually a fellow, it's like a neighbor to me in almost the closest way you can get in the Bevy community. He's also living in the Netherlands. And so yeah, I'm going to put Jillis on stage now. Without further ado, welcome. And let me put your slides up here. And yeah, I think everyone is excited to hear what you are working on. And I don't want to spoil anything, so I leave the stage to you. Thank you so much.
All right, thank you, Stefan. So I started or found out about Bevy like 2 years ago by now, I think. And I really fell in love with Bevy and the ECS and Rust and everything, and the community, of course. But like many people, I quickly noticed that for the audio stuff, there were still quite some things missing. And it started. So, for example, you have basic spatial audio, but there's no effects that are supported out of the gate. So, you could implement them, but it's not easy. And yeah, like many people use Bevy Kira Audio, and which also it's great. It's already a lot better, but still no effects like reverb and EQ. For example, EQ is nice if you want to have this underwater effect. And there's, well, back then there was no audio working group yet. So, I was kind of seeing that, especially compared to something like rendering, like not a lot of people were pushing the audio forward with Bevy. So I started looking around, and first, because I don't know much about, or back then I didn't know much about game audio. So I started looking around, and I first wanted to look at like what's the state of the art. So I quickly came across Fmod, which is an audio engine. Was used in many games, and Fmod is very nice because it's artist friendly. It comes with like a whole studio that you can use. It has adaptive audio support. So, for example, let's say you have a tree somewhere and you can hear the birds chirping, and if you get closer to the tree, they don't just get louder, but you also start hearing like more birds and different types. That kind of stuff is really easy to set up with Fmod. And it also has spatial audio basics, of course. And then I started looking and found that someone made a C bindings and wrapper for Fmod, so you can use it in Rust. And then there was also someone who made a Bevy Fmod, so you can use this wrapper with Bevy. And I contacted, so I started using this, but I noticed it was a bit bare bones at the time. There was still a lot of setup required, so I contacted the author, and luckily they were willing to work together on this. So now we made it really easy for people to implement spatial audio with Fmod. So for the camera, just add a spatial listener bundle, and then for the audio source, first you kind of load the samples, create an audio source, and then pass that to a spatial audio bundle on the the emitter of the sound. And then I'll actually show you what that looks like and sounds like. So if I turn up the volume, so this is the built-in. So what you're seeing here is Fmod, and then here's the built-in Fmod spatializer. So you can notice if I move towards the audio source, it's louder, and if I look away from it, you can hear like where the sound is coming from. So let me move away a bit, and then it's like really easy to add effects, whatever you want. You can do it while the game is running. It's very nice. However, there's still, I was not yet completely happy. There's some things missing. For example, let me actually turn it down real quick. So you have this environment, but it does not sound like the environment yet. And if I, for example, move through this wall, I can still hear the sound. And another thing, which is really interesting, is that, so right now, if I look left and right, you can hear where the sound is coming from, left and right, but up and down, there's no difference. But it is actually possible. And that's using the HRTF, which is the head-related transfer function, which is the effect that's commonly used to create this binaural audio effect. So let me show you a quick example of what that sounds like. And you have to notice that, or it could be good to know that this HRTF, it's unique to everyone. So if you don't hear it immediately, that's fine. It could take some getting used to. So there you could I hope you could hear it. Hopefully it's not too much delay between the video and the audio, but as the object is getting below or above you can actually hear where it's coming from. It's a really nice effect, which currently not supported by Fmod. So, still looking around, and then I found out about Steam Audio. And there's a very common misconception with Steam Audio. People think it's an audio engine, but it's actually just a library of audio effects and the simulations that come with them. And for this is actually really nice for us, because that means it's game engine independent and audio engine independent. So we could actually try to integrate this with Bevy. And just if you're curious, there are also some other similar libraries like this. But for example, Resonance Audio, it seems kind of archived, like it's not being updated. And then there's Meta XR Audio, but that's closed source, and that's going to play a role later. So yeah, very basically how Steam Audio works is that the audio engine will provide the samples, the audio samples, and then those get like filtered by Steam Audio, and those filters, their parameters are then adjusted by the simulations whose inputs come from the game engine. So Steam Audio has a C interface, and there were people that wrote like Rust bindings for it. So I was able to try to integrate this with Bevy. First, I tried using the Bevy native audio. I was following this decodable example, and I got it working like for a single audio source and a single object in the scene. But this decodable interface, it's not really meant to create like an audio effect. So it's very open-ended. So while it was possible, the code was scaling really badly. It was really a lot of boilerplate. Also, my Rust skills back then weren't as good. So then I noticed that Steam Audio had a Fmod integration ready to go. So that's nice, because then this integration is already handling like a lot of the audio processing. And the only thing you have to do is from the game side, supply all the inputs and do the simulations on the geometry. So I got quite a bit of that working, and I'll show you a little demo of that. So you can see how changing the environment actually affects the sound, and it's a very easy way to make the audio like really immersive really quickly. Here's one more example. So I was working on this, and it took a lot of time to integrate these features, because you're working with this C interface and it's not always the easiest. And then at the same time, Steam Audio got open sourced. It's very nice to see a company do something like this. But I looked into it, and 31,000 lines of code, and also noticed that as the code complexity went up, the amount of comments went down, and the amount of tests went down, and the variable names became like X, Y, and T. It's like just really difficult to read. And also like the organization of the code base, it's just one big list of files. So it was pretty daunting. So I was like, I'll just continue working with the C bindings if that works. But the more and more I continued, the more I noticed that I kept running into different kinds of issues. First I would run into issues with the bindings that I was using. I was like combining the best parts of 2 different bindings that people wrote for Rust. So I was running into issues there. I was running into issues where the documentation from Valve was not clear or was just missing information. And I also had issues where, after I fixed all of these things, I would try it on Linux, or the other way around, try it on Windows, and then I would run into another crash. All these were all like memory violations, so really difficult to debug. So it felt like, the surface area of things I had to worry about was like growing really quickly by using the C interface, because there was, still a lot of features to integrate. For example, in this demo that I showed, everything was being done in real time. So bouncing all the rays, that takes a lot of computation power. You want to be able to bake it and do that kind of stuff. So slowly I started thinking, it would be nice if there was a port of Steam Audio completely written in Rust. I don't want to be that guy. It's like, oh, we should rewrite it in Rust for no reason. But after months of agony, it started to become kind of appealing. So I started doing it and made some progress. So if you want to check out the repo, it's right here. It's still kind of messy because I'm still following the same structure as they do. But yeah, anyways, right now I'm testing with Kira, which is a Rust audio engine, and that makes it really easy to test out the effects, because remember, it's not an audio engine, so I actually need to work together with an audio engine, like implement the effect to actually hear it. So let me tell you a bit about how Steam Audio works, how we are integrating this. So I think to put it really basically, you can split it up in 3 major parts. One is the HRTF, the binaural audio I talked about earlier. It's not in the slide, but I also haven't gotten to it yet. And then there's the direct effect. So imagine drawing a straight line between the listener and the audio source. And direct effect is everything you can get from that straight line. So the distance gives you the distance attenuation, and also like the left and right panning, or if there's an object in between, then it should be, the volume should go down, all that kind of stuff. And that's then driven by the simulation, which is driven by the game engine. And then there's the reflect effect. So that's everything that's not in a straight line. So that's all the rays that are bouncing around and then giving you this feeling that you're in a cave or outside, that kind of thing. So the first thing I'm working on is the direct effect, because that's the most simple thing to do. And it's also a lot of kind of like a basic building block in the Steam Audio thing. So I got a proof of concept working of the direct effect integrated with Bevy and Kira. So it's all pure Rust, and it feels great. And I was integrating into with Bevy using a Kira audio engine that the audio working group was making. So it was like an experimental audio engine. I took a bit of a gamble by integrating it with that, because I wasn't sure yet if that was gonna become the main engine for Bevy. Eventually they moved away from Kira, so I kind of had to put that project to the side, or that integration. I was also thinking about integrating it with Bevy Kira Audio, because that's currently, I think, the most popular audio solution with Bevy, at least the most popular open source one. But sadly, it's missing support for Kira effects. So even though I have it implemented as a Kira effect, Bevy Kira Audio does not support it yet. So if someone wants to tackle that, that would be awesome. But right now, focus on porting or integrating the direct effect with Fmod, which is also going quite well. And I think that's also, so the reason I'm focusing on Fmod here is I think a lot of people were trying to use the best audio engine that don't want to run into any missing features. They're more likely to be using Fmod anyways, or already. So I thought it would be nice to kind of add some value there. And recently I got some stuff working. So, and I think that's also like the first Fmod plugin. So the plugin is the Steam Audio effect. And I think it's the first Fmod plugin that's written in Rust. If I'm wrong, please correct me. So let me show you that. So here we have the built-in spatializer from Fmod. Then here I can add a custom phonon spatializer. So that's my work. It's still a bit messy at the moment. I have to do the styling on this and make it a bit more user-friendly. But here it is. So it sounds kind of the same right now. Let me turn up the volume a bit. So we got, the song is fading out. We have to wait a second. There we go. So we have the left and right panning. And then the distance attenuation. I actually forgot to enable that. There we go, distance attenuation. And then I also have a demo here, which shows the, so with distance, there's this air absorption effect that Steam Audio does. So the further away a sound is, the higher frequencies will like lower in volume. So that kind of gives this pretty realistic effect of like modeling the atmosphere. And another thing is if I move into another room, it becomes quiet because now I have the audio occlusion. So it's checking if there's any objects between the listener and the audio source. And I was gonna have another demo here to kind of show like the volumetric audio occlusion with like arbitrary geometry, which can also move around, but I didn't have the time to get to it. But you just have to believe me that it works. So yeah, that's quite a lot of things that I was able to work on. And let's see. What is the current progress? So with just the direct effect, that from the 31,000 lines of code, that's now 2.7K translated, and that turns into 2.1K lines of code in Rust in my case. So of course, with C++ you have a lot of header files, so I think that's making the biggest difference here. I did notice that with Rust sometimes things are a bit more verbose because they're doing stuff that's maybe not always as safe. So with Rust you have to kind of work around that. And then there's 10K lines that I've kind of crossed out and said like, I'm not gonna translate those to the Rust version, and that's for a few different reasons. So. Of that 10K, there's 7.7K that's like an API layer. I think the reason they have this API layer is to allow Steam Audio to be used with other programming languages. But I think since Steam Audio already fulfills that job, then for my Rust version, I don't need it. So I'm gonna try and see if I can get away with that, because that's a lot of code. And then 1.6K is I've replaced by using Glam and D-Array. So it's simple, add the dependency and you're done. And then another 700 lines for Perry for the raycasting and that kind of stuff. All right, so that said, there's still a lot of stuff to do. The binaural effect I talked about, reflect effects, and the baking stuff. I would also like to see the Bevy Kira audio integration, but for me it's a bit lower priority. Yeah, and then lots of testing, benchmarking, and code review. So if you saw something you thought would be interesting to help out, please contact me on Discord, IXML. I would love to work together. I can help you get started, get oriented in this massive repo of theirs. And yeah, I think that's about it. So let me know if there are any questions.
Jillis, thank you so much.
Yes.
That's a daunting task to port such a thing to Rust.
Yeah.
I think we still have some echo from your audio. You were right.
Let's see.
But yeah, we have a bunch of questions. It's going to be interesting. We probably have to open some of them up for the panel in the end. But the highest voted for is, will you continue using Fmod, or are you going all in with Kira now? I believe this question was answered before you kind of tapped onto that in the slides.
Yeah, so I think, so one reason I'm going for Fmod at the moment is because I know, it's industry standard, so I know I'm not gonna run into any missing features that I need to implement all this stuff. I'm still using Kira when I'm working on the core of Steam Audio stuff, because then it's an easy way to test things out. But yeah, for integrating it with Bevy, it's this issue. And I kind of looked at it, but I'm not familiar with Bevy Kira Audio. And from what I saw, just at a quick glance, it's quite a fundamental change to the crate to add support for these effects. So yeah, but
okay,
yeah, it would be cool.
I think that was actually also a question, like what's the effort to actually add these effects to Kira?
Yeah. So currently, so Kira has a concept of tracks, and then you add the effects onto the tracks. And I think the issue is that Bevy Kira Audio, it has a concept of tracks, but it doesn't actually use the Kira tracks. So you cannot yet add the effects to it.
Okay, but it's really just the glue essentially that misses that, right? Kira knows how it works, but it's just the Bevy wrapper on top that doesn't. I mean, it sounds solvable for someone that wants to have a nice entryway into contributing here.
Yeah, exactly. And I think once this issue is solved, then from my side, it will be like maybe a week of work to actually integrate it with Bevy Kira Audio. Because that part is not too bad.
But I guess it makes sense to just keep supporting both anyways.
Exactly.
If you start being able to support Kira,
Yeah, and then at some point, I'm hoping that the Bevy audio working group, they're working on a new audio engine, which has like, I think the main goal is to have like really good, how do you say, integration with the ECS. And I'm also kind of pushing them to, add support for custom effects from the beginning.
Yeah,
I think that would be great.
I mean, that sounds definitely like something you should be involved so that it's workable for you right from the get-go. So the next question is from Grandpa asking, back in my days, we had sound cards. Is that all of this, is all of this mixing of tons of channels happening in CPU these days?
Yeah, I think it's all CPU based. I'm too young to know about these hardware sound cards. I know it's a thing, but yeah, no, this is all CPU. And then of course, when you're doing the simulations with the geometry, right now it's CPU based, but I'm hoping in the future to do also some GPU based stuff.
Is that something Steam Audio does?
Yes. I think especially if you're making a AAA game, it still takes a lot of power to do all these ray traces and all the bouncing. So you kind of want to either do it on the GPU or you do it on the CPU and you bake it beforehand.
Yeah. Is this port a lot of unsafe? Is another question.
Yeah, so right now for the core of Steam Audio that I've ported, I've used 0 unsafe. So that's good news, I think. And I've been really, enjoying just working with Rust. It feels really nice. But then, I started doing this fmod integration, and I had to work with the fmod C bindings. And then, of course, that caused a lot of issues and bugs that are just crazy. That, one day it will work, and then start my computer the next day and it doesn't work. And then, good luck debugging that without any debug symbols or anything like that.
Yeah. That actually brings me to another point. In terms of platform support, this is all going to be cross-platform, I assume, right?
So currently, so if we ignore fmod for a second, I've not written anything platform specific. At the same time, I don't have much experience with web, so maybe there are some pitfalls that I'm not aware of. And then for the fmod stuff, fmod supports a lot of platforms, including web. But then recently, I saw like a bounty of $1,000 someone posted to get fmod working with Rust and web. So apparently it's not trivial to add support for that.
Yeah, I can imagine.
Yeah.
No, I think it's there's always these worlds colliding of mscript and C++ stuff and how to make that communicate with our WebAssembly export.
Yeah.
But yeah, it's just a temporary issue until Bevy has their own audio engine or you make Kira work, right?
Exactly. Yeah, that's also something that I really hope to see, that in the end we have just a fully open source solution, but just as great as these industry standards.
Yeah. So I would say this is the last question before we open up the panel. Is Steam Audio still actively maintained and extended by Valve? Is it moving? Is it a moving target for you to translate?
Yeah, so they're still doing updates. Their latest or biggest update was when they released what's it called, Half-Life Alyx. So a VR game. So they really needed to up their game in terms of immersive audio. And even I had like a tiny contribution because I mentioned the documentation that was sometimes lacking a bit. So I wrote an issue about this once, and after like 5 months, they did actually acknowledge it and fix it. So that was pretty good to see.
Nice.
Yeah, so they're still working on it, and I think they're currently transitioning because they went open source, of course. So I think they're transitioning from their internal version control to GitHub now, but I think we're going to see more activity on there.
Yeah, I can imagine. Okay, cool. Jillis, there's a bunch of more questions, but I would pull up the other speakers and we can go through the rest together. Maybe there's some comments and contributions by the others. I would still want to thank you for your presentation. It's super exciting to have this project going on in Rust. I'm really hoping that at some point people will use the Rust Steam Audio instead of the actual one because of its safety guarantees. But yeah, then we also have the whole conversation about consoles, right? So that's a whole different can of worms. But it's a really cool project, and I can't wait to see this working with Kira, because then I personally can at least use it on the web as well.
Yeah.
Cool. Okay.
Yes.
Let me put your slides down. Let's get Thierry and Zicklag back on stage. Hey, guys.
Hey.
So, Zicklag, I think you also have some experience with WASM and exporting to the web, right?
Yeah.
Did you? When we talked about this just a second ago, I thought with the conversations about Lua and all these things. Did you also run already into issues where you wanted a like a legacy sort of C library or something and wanted to run it inside a project too? Because it sounds like it should be trivial to connect those two together now with everything you did there.
Yeah, no, that's absolutely a challenge because it's like you have these C++ programs and they run in the browser and they compile to WASM and that's great and Rust does too and you'd think you could use them. But the problem is that WebAssembly doesn't have a linking standard yet. It's something I've looked a lot into. It looks like they're moving on to the component model maybe instead of a like a typical like assembly linker like LD or something like that we would normally use. So basically, even though you could create a WASM binary for the C++ program, you create a WASM binary for your Rust program, there's not a way to link or resolve the symbols to the C++ library from the Rust WASM library. So you're in kind of a sticky situation because the only way to get to them then would be to like traverse through JavaScript. So from Rust WASM to JavaScript to the other WASM and back, which is kind of defeats some of the performance advantages of the WASM for one. So there's like Emscripten is the only solution I've seen so far. If you opt out of WASM 32 unknown Rust target and you use the Emscripten, and Emscripten has a way to do some sort of linking using their custom WASM API or something like that. So that's the solution I've heard is basically you have to use Emscripten if you want to link a Rust WASM to a C++ WASM, which apparently is they've been doing it for a while, so it does work. For us, it was just like I want you just to build a clone our repo and just build it for web as easy as possible, as rusty as possible. So that's why, because we were looking at Lua implementations, right? And like there's obviously C++ Lua implementations that we could have maybe used. There's ports, bindings to JavaScript and all of that, but then it wasn't going to be easy to link to Rust. So the solution was find someone who rewrote it in Rust too. So yeah, unfortunately,
there's always someone.
The WASM folks haven't figured out how to make that smooth. It looks like they'll have it one day, but yeah.
Yeah, that sounds like a whole different conversation. I actually managed now that you mentioned it, I actually managed to get a Rust-based Emscripten dynamic library with the old Godot 3.x Rust bindings that we had to work with the web exported Godot game. That was a nightmare, and I didn't want to maintain that ever. It was more like, cool, it's possible. Okay, I move on now. But yeah, we certainly need something to make these things be able to talk to each other. That's a real shame right now. Thierry, do you have any experience with the web, especially now that you're working on Rapier that has a significant web export?
No, I won't go into detail for that, but I was thinking about the CRABI. Is that something that's relevant there?
The what?
The CRABI. It's it's an ABI for Rust.
It's so the closest thing we have right now is actually the component model, which Rust actually recently started to add support for the new WASI preview 2 or whatnot. So that it's still like stabilizing and stuff like that, but that lets you build the WASM components that can export things to other WASM components. So that is actually getting some traction soon, and I think that's why they have postponed a typical linker, is because they're moving towards this component direction instead of that. So we might be able to actually do that. We might actually be able to do that today if you got the C++ library to build to a WASM component. So that's actually something to look up. I was looking at using WASM components for something totally unrelated at some point and didn't get totally into it. But so that might actually work. Because yeah, basically once you build a WASM, it has to be totally supported by the WASM ecosystem. Otherwise, or somehow working the C++ build into Rust C or something like that. So I don't know of any ways to hack that in. But hopefully components might make that easier. That might be possible today. That could be interesting.
Okay. That sounds like a talk for the next time. And it is somewhat related. So I'm asking you, Jillis, are you also planning eventually then, once everything is working and is awesome, fast and safe and all, to also write a C API so that the rest of the world can benefit from this as well?
I mean, if it's actually better, then yeah, we should do it, right? But yeah, there's still a long way to go. And I still have to look into it, like what kind of tools does Rust provide to create that kind of C interface. I hope it's not as bad as this 10K lines of code that they have the C++ version.
I think
No, I think you will get a 10K auto-generated file.
Yeah.
Yeah, I don't know what there is for auto-generating, but as far as, I mean, if you go to C API, C is super kind of simple. I mean, obviously you got pointers and danger and all that stuff, but I've seen other Rust crates have C. You can do it in like totally separate crate, which is nice because you basically just need to make your extern C functions so that other people can call it, and then you call all your normal Rust functions on the inside of that. So it seems like
Yeah,
at the very least you could have some. It could be like kind of maintained independently, or even at a different quality level or whatever. So it seems like something that's real possible for as someone who's interested in or savvy to that too, if they wanted to like adopt it or something like that.
it's definitely possible, but it's a little bit more complicated as soon as you want to do types between the boundaries, right? And I'm pretty sure Jillis doesn't want to write C represented types all the time for the core library. So you might end up having to have like wrapper types around it and stuff. But yeah, it's definitely possible. I mean, there's a bunch of examples for that, right? And I mean, I assume Rapier has to have some sort of similar thing as well to get out into JavaScript, right?
Yep.
Yeah. Speaking of Rapier, Zicklag, what kind of physics solution are you using in Bones?
Oh yeah, and so like, but right now for physics we mostly dish that off to the games, or so you can use whatever makes sense for your game. We might be able to pull some of what we've got for physics and Jumpy. We're just using Rapier, but we've got like a funny combination because we got like obviously kind of a very specific like 2D physics that we're going for. So we run the Rapier like physics and collision pipeline. So it generates the collision world and optimizes raycasts and all that stuff. And we use mostly the collisions during the normal gameplay. And then when you go into like ragdoll mode after the player gets hit with a sword or something like that, then we turn on the dynamics for that player so that they bounce around like a ball. So it's kind of a combination where most of the logic, we're kind of mostly doing manual logic for what happens when you hit jump, how does he handle when he touches walls and sliding and all of that, because it's very simple, mostly just sliding boxes around. But then it's fun, it's very cool because the Rapier, it was mostly raycasting based, if I remember right, as far as how we don't make sure you don't go through walls and all of that stuff. We're just using Rapier raycast, and it handles making that performant, keeping the colliders up to date. So we've got basically this synchronization layer there, and then but very handy just to be able to say turn on normal physics and have them bounce around. So and that's something we might get to use more for different effects throughout the game. It could be fun.
Interesting. And is that because you mentioned it's heavily networked and rollback and all of that? Is that does that apply to these ragdoll animations? I assume not. That's basically like, okay, he's killed, so the rest is now just like
no. Rapier actually is great. It's one of the few physics engines that has a deterministic mode. So you can tell it's slower. You tell it to go. I'm pretty sure most of what it does is it just makes sure it uses software implementations of certain functions like tangent and sine, and I think they're called transcendental functions for some reason. But anyway, use the hardware implementations can differ on those functions. But the hardware implementation is faster. You could just pass the feature flag to Rapier, and then it will use the software implementation that will run the same on any platform that supports the float standard or whatnot. So that's really handy for us because that's a lot of the reasons you couldn't like do a rollback mode for like Godot or Unity or Unreal and stuff like that. A lot of the limitation comes to that physics engine not being deterministic. So that was really handy for us. Rapier is a big win there.
Nice. Yeah, that's cool to hear. Yeah, I think that's really one of the USPs of Rapier. As you mentioned, it's pretty unique to support that deterministic physics there. I think I just recently read a blog post by the Box 2D guy about how the old Box was not supporting that, and what efforts he had to go through to actually support that in the 3.0 release. So that's it's still an interesting topic, like what you have to do to make it really solid across platforms. Jillis, I thought about you also must have gone through similar issues as what you pretty much usually solve with the physics engine, right? Like in terms of finding collisions, is there a straight line between you and the audio source and stuff like that? Are you using any of the existing crates, or do you really just translate Steam audio one by one and they are doing this themselves?
No, so for that I use Perry. I was able to save 700 lines of code by using that.
Yeah, okay.
And yeah, I mean, it's like using Perry in that sense, very simple. So I could also easily swap it out, maybe with something land-based in the future, hopefully. I think that would be nice.
Yep.
Yeah, the Rapier, one of my favorite things was how it kind of like Bevy, you can pull it apart into pieces if you need to. So it's like Perry is just the collision detection. It's the very raw math function collision detections, or the collision pipeline or the physics pipeline. Because we actually started off in Jumpy just using Perry. And then we wanted, as we needed to optimize it more, it just became easier to layer on more Rapier. So, but that was very handy.
Oh. So that's building in the other direction in comparison to Bevy.
Exactly.
Yeah. If anyone in the audience wants to know more about Parry, the documentation is a bit difficult to parse, but I recommend to go to look at nCollide, which was the ancestor of Parry, let's say. And yeah, there is a way more digest documentation on nCollide.
Cool.
Okay. And it still applies to the algebra,
yep,
or
mostly.
Okay.
Yep.
Cool.
It's the whole Rapier stack was built on algebra. There was so it dates back to 2015. That's Rust 1.0. And then there was so algebra, which is mathematics. Then Parry for collision detection. Then there was nphysics in 2015, and then nphysics. Just this block was rewritten in 2020 for performance reason and organization. So yeah, and nCollide was before Parry, but it was just rebranded, and most of the code is quite similar.
Okay. So you one day will copy over the documentation as well.
Yep.
Nice. Okay. There's actually an interesting question in the chat that I think is very perfect for a panel like this. Like, what do you guys think is the best first engine to learn for a new developer? I guess in the Rust space.
Well, Bevy is easy to get started with, and right now Bones is not ready for Bones. To be clear, has plenty of rough edges. So I haven't tried Good Game Easy though. So I mean, mostly all I've tried is Amethyst, which is superseded by Bevy, and Bones, which I'm in the middle of making and isn't ready yet. No, and so but no, we actually have and we got some good feedback recently from new guy who is trying, or who came in, found Bones. He was comparing macro quad and stuff like that, and Bones seemed to fit his use case for the networking perspective, because that he wanted to do like local type experience except online. So and he confirms, yes, it's it's rough around the edges. It needs some help, but it's good to get someone else also using it, so it's not just like the insides of Jumpy outside of Jumpy. And so hopefully we'll have he's got good ideas and stuff on how to help bring that in. So hopefully we're going to have some more influence on refining it a little bit, making it easier to use, and just having other games as a reference for, okay, what do different games need to accomplish? What kind of different use cases do we want to help make easy? Because Bones is very much focused on the make it work for a real game first, then make it easy. So the Hello World in Bones is harder than the Hello World in Bevy, but it's a lot similar too. So probably easiest, especially with all the resources around and stuff like that, to get into Bevy first. But if you're willing to experiment with something a little bit different, and then Bones is there, and I don't have much experience on anything else, so someone else would have to speak for it.
Yeah, it also depends on how comfortable you are with ECS, or comfortable to try ECS. If you're more from a background with traditional game development, with the update loop, with simulation, rendering, probably I've used a bit GG Easy before Bevy, and it was great. So try it out. And MacroQuad is also a strong choice there, and especially for its we were mentioning compile times. MacroQuad is very light. Yep.
Yeah, actually, I know I know at least one developer who had mentioned not liking the feeling of being restricted by the framework of like ECS and stuff like that in general. MacroQuad, I haven't used it much, but it definitely seems very light on that, very easy to just get stuff drawing. So probably one of the more fun to play with, even if maybe I'd use something else for once the game needs to get fleshed out more and such.
Yeah, I think macrocode is really more like the rendering module of Bevy in a sense, but not using web GPU there. So, Jillis, what's your opinion? Oh, sorry.
Oh no, continue.
Okay, so yeah, I've only used Bevy, and coming into Rust and ECS at the same time, it's pretty difficult. But I think for me, I really believe in the ECS. It's a great way to build games that are easy to make bigger, and so in that sense, I would go for Bevy or something ECS related. Yeah.
Yeah. The only thing I can say to that, I don't want to really go into the whole this engine versus that engine, but the layer about the ECS topic, I think what's really surprising to me is that I talked to a lot of people in the Bevy community, and it's the first time I think where I'm talking to people using Rust as like the second reason. They are coming to the Bevy engine because they were looking for something that is totally natively ECS driven. And then they learn Rust because it is requiring them to be aware of Rust. And the fun experience of those people is that they learn a very kind of different Rust at first. It's like the easy mode Rust when you're coming with this ECS entrance, right? You basically don't have to worry about borrow checker and lifetime stuff anywhere because you have nice integer indexes into stuff. It's pretty much shielding away especially in the first phase, what kind of intricacies you are exposed to when you're suddenly going deeper, and you have to look behind the curtains. So I think it really depends on also what background you come from, right? Some people are really hyped about ECS, and they are tired of waiting for a proper solution in Unity and looking around for alternatives, and they end up with stuff like Bevy, and then they actually at first think, well, this whole rusting is not as hard as people say, until they have to break out of it in terms of the world that Bevy presents at first. But yes, that's just an interesting observation that I didn't expect before digging that deep into the Bevy world.
Yeah,
that's
no,
something I definitely noticed when I started doing my Steam audio stuff. It was also my first time like actually really writing Rust stuff. At least it felt like that way.
Yeah.
Oh, that's interesting.
Zicklag?
Yeah, I saw or I read like the talk by Kyron from Chucklefish about the ECS, how it was similar
Mm.
to the almost like the old games where you had to line everything up in memory and you only had so much memory, and then you would operate on that memory and just use indexes into it type of thing. And coming from like not having made any real games or anything other than teeny tiny demos before, the ECS, I was like, it's the answer to all my object oriented problems. Because there was always this problem where object oriented tended to work great if you knew everything about everything before you started writing the code. But the fact of the matter is you find out, oh, that's not fun. Oh, you need this now, and you couldn't grow it, which was really frustrating. The ECS seems kind of like this great balance between it's dynamic in that you never know what components are going to be on an entity, but it's static in the fact that if you got that component hasn't changed. Or that component is static. So it's kind of like a good balance between static and dynamic typing, which seems to be appropriate for games. But then I think also people will be like, you'll try to shove everything into the ECS. And then sometimes that's not the easiest thing to do because it's not necessarily fitted for everything. And it's okay to have a resource that contains like this collision bounding hierarchy, cache and stuff like that. Like it's okay to have these big resources. It doesn't all need to be on the ECS or stuff like that. It's kind of just
Yeah.
it's always a learning process figuring out what to use where.
Yeah, of
Sometimes
course.
not the same tool for everything works. Obviously we have multiple tools. So, but
Yeah, no,
no,
I mean
definitely.
that's the general wisdom, right? Don't make everything a nail just because you love the hammer.
Exactly.
Let's maybe finish with the last two questions. Zicklag, to the uninitiated, how does Bones schema compare to Bevy Reflect?
It works a lot the same. If you're used to box Dynany, Bevy Reflect is probably a little more familiar. Because we had to have a stable memory layout, like you can't just have a dynamic vector. You have to have an SVec or a schema vect. So like because the vectors in Rust can't store any kind of type that hasn't been in Rust before. So like we have it, whereas you'll access everything in Bevy Reflect through traits, like you'll get like this dyn list or a dyn map object in Bevy's or Bone schema. You get like a concrete SVec struct or a SMAP struct. So it's kind of almost a superficial difference. It's in a lot of cases, but it gets different when you try to do scripting maybe or you integrate with more native stuff. So really
So you see
it's very
boundaries.
similar.
So you see boundaries with Bevy Reflect that you don't have in Bones.
Not boundaries until you want to mess with the pointers directly, maybe.
Okay,
so
no one wants
so
that.
yeah, no, it's more like honestly, so I wanted to make a scripting solution that I wasn't afraid the scripting interface was going to be a performance problem. So with Bevy Reflect, you have to keep calling those reflect function pointers. You get a dyn reflect, right? It actually points to this thing that says, here's this function pointer for listing the items in the vector. Here's this function pointer for this, and it could be different every time. You couldn't. We still have to do that for a couple things, maybe like vectors and stuff, but you don't have to do it with structs. You get a pointer to the struct, and then if you cast it in C to a type that matches, then you can just access those fields just like normal C struct. So again, I'm not sure in real life whether or not that like prevents performance problems you would have with Bevy Reflect or not. But at the very least, the hope was I was just going to start with the simplest thing I knew that I could make work, and that if we need to integrate with a Lua just-in-time compiler that had fancy ability to directly access C function pointers, then, or not function, just C type data pointers and stuff like that, that it would just be able to access it as fast as possible, like we didn't have a scripting interface in the way or something like that. So that was the hope. But really, as far as you want to use one or the other, I guess you'd have to try it and see if you like one more than the other. I think a lot of the differences are probably superficial. Again, unless you're literally wanting to cast these pointers and you have the schema and trying to get an extra performance gain out of that.
Okay. I mean, that's definitely something time will tell in the end, right? Once we have a more solid scripting solution on Bevy side to really be able to compare that.
Yeah, that would be interesting, actually.
Yeah, definitely. Jillis, last question for you. Have you looked into using actual C++ bind gen? The people at Embark used it for physics in the past. Because I think this is related to the beginning of your presentation when you were still using the Steamworks, the Steam Audio C++ SDK, and you mentioned, I think, that you were using it via a C API, right? Which is already like an indirection on another indirection.
Yeah. No, I was just using these crates that other people made. Honestly, at the time, I was very new to this stuff, so I didn't really explore in that direction very much, because all I knew is that these two crates that I was using, I was taking like the working parts of each, and it was still a bit painful, to be honest. So that's why I quickly wanted to kind of move away from that.
Yeah. Anyone interested in that? I think. Sorry.
How long have you been working on the? How long ago was it that you were trying the audio, the initial bindings?
I think it must have been like almost a year ago by now. Yeah.
Okay, cool.
So like even before it got open source, I was already using it and trying to integrate it. Yeah.
Oh, cool.
Was it, how did that work when it was still closed source? Then it must have been basically only C bindings that you could use to it, right?
Yeah, exactly. Yeah. And I think they also recently added support for like doing static. I don't know. Like right now, you have to dynamic link your libraries.
Yeah.
It's also very annoying. But I think they recently added support for static linking as well.
Oh, that's nice.
Might help out. Yeah.
Okay, I think that's the end of our questions here. Is there any last comment or a question maybe from you guys towards each other?
No, I think that's good.
Thank you for socializing. I can't read, but yeah, it serves as a teaser.
Nice.
Okay.
Is that like an activity card?
Yeah, I have my first prototype printing.
Ooh,
wow.
Nice.
Awesome. So yeah,
cool.
I want a t-shirt as well.
What?
I want a t-shirt as well. The Bevy t-shirt.
That's for the cards, yeah.
And there is there is a Rust meetup at Paris in which I will be showcasing that.
Oh, a Rust meetup, did you say?
Yeah, at Paris.
Nice.
In September 24th, if I recall correctly. Yep.
It's a bit too far. But yeah, it's I'm curious to hear what kind of reactions you get there, and obviously to see the whole collection of cards.
It will come.
And then I assume next Game Jam, the web version on itch.io.
Maybe.
Okay, guys, it was a real enjoyment to see all these projects and how they are going along. I think it's very inspiring to see what people are doing in these different areas. I mean, it couldn't be more different almost in the terms of presentations that we had today. And it's also cool to do these cross project kind of presentations, because I think it's super valuable to see what happens on any of these Rust game projects or game frameworks, right? And this is a shout out to anyone in the audience if you guys are familiar with the Fyrox engine. That's probably one of the bigger Rust game engines out there as well. Then definitely reach out to me. I would love to have like a little showcase or show off between Bevy and Fyrox in a future meetup as well. Okay, guys, thank you so much. I will close this stream out now, and I'm excited to see not only Thierry but all of you in follow-up meetups again.
Okay.
Yeah,
For sure.
can't wait.
Okay, guys, thank you so
again.
much.
Thank you.
Thank you. Bye-bye.
Okay, so this was the sixth meetup. I don't want to keep you any longer. It was a pleasure. Thank you guys for joining, and find us on rustunit_.com on YouTube to subscribe to see the recordings later. I especially heard in chat that we had problems with mono, stereo kind of stuff of Jillis presentations. I'm pretty sure this will be fixed in the recording because it's going to be having all the audio channels, and I'm going to be able to upload that in HD. Yeah, if you're not subscribed yet, go to bevygamedev.com to subscribe and join the meetup to not miss out on any of the future events. And oh yeah, we are also hiring at rustunit.com, so please reach out to me. And yeah, see you next time.